In this section, we will be looking at how to approximate the area and what that means as far as the definite integral. The derivative gave us the slope of the tangent line to a function. The integral is going to give us the area of a region under a graph. But before we use calculus, we're going to go back to basic geometry, and we're going to use what's called Riemann sums. Don't get scared. That just means a bunch of area of rectangles to approximate the area under the graph. We're going to look at this region here, and we have some function, and we want to bound it by vertical line A and B and the x-axis. And I want to know, what is the area of that? Well, if it was a square or a triangle or something like that, we have formulas, but it's not. So how can we approximate the area? Well, one way is to draw rectangles, which I've done here. And so I've divided, let's see, I have 1, 2, 3, 4, 5 rectangles. And let's say they're of equal width. And so I would take B minus A, because that would be the distance from A to B, and divide it by 5. And that would be the width of each rectangle. But what about the height? Well, you can take the height in different spots, but notice the height on the function is about in the middle of that rectangle. So that would be f of x, but we need to know what x is. And then we have the height here, the height here, the height here, and height here. And so remember, the area of a triangle is just base times height. So if we knew all the different heights, so height 1, height 2, 3, 4, and 5. If we knew each height and we knew each width, we would just multiply base times height, add up all 5 rectangles, and that would be a good approximation of the area. Because you can see some of these rectangles go over the function, like here and here, but some of the rectangles go below, like here and this part and so forth. So it's not exact, but it's pretty good approximation. So what we have is delta x. That delta x is the width of each rectangle, and f of x is going to be the height, and we're going to have different x's, x1, 2, 3, so forth. And when we add up all those rectangles, we're going to get an approximate area. And this sum is called a Riemann sum in honor of a mathematician. So let's go back to some basic geometry. On number 5 out of the book, it says let f of x be 4 minus 2x. Now, you should know that that's a line, and so part A says to sketch it on the interval from 0 to 2. So what you can do, remember, to graph a line, you can say y equals mx plus b. You can plot points, but basically when x is 0, y is 4, and when y is 0, x is 2. And so you have this triangle. Part B says use a Riemann sum with 5 subintervals to approximate the area. But you know what? Instead of doing that, let's go directly to Part D and find the exact area. How can I do that? Remember, it's 1/2 base times height. So that would be 1/2. The base is 2, and the height would be 4. So the area of this triangle is 4 square units. So that is the exact area using geometry. Let's go back to Part B, saying use Riemann sum with 5 subintervals. What does that mean? I've taken this, remember this is still 0 to 4 on the y-axis, and that represents 2, but I've split this up into 5 units. 1, 2, 3, 4, 5. How large is that? Okay, so the width is going to be 2 minus 0, 2 minus 0, divided by 5. So 2/5, or if you want to use decimals, which is okay, is 0.4. So now we know the width of each rectangle. So it says use a Riemann sum with 5 subintervals To approximate the area of R, choose the representative points to be the left endpoints. Left endpoints. All right, so I have to draw 5 rectangles, and I'm going to use the left endpoints. So that means my first endpoint is 0. And so I have this rectangle. My next endpoint is going to be 2/5 or 0.4, and I would go up to this height. My next one would be 4/5, which is 0.8, and I would go to this height, so I'm going up to the line. The next one is going to be 6/5, which is 1.2, and then the last one I think would be, let's see, 8/5, which is 1.4. So those are the areas of each rectangle. So hopefully you can see that the area I'm going to use is going to be much larger than the area of the original triangle. The area would be approximately equal to 2/5, because that's the width, times f of 0, because that's the first endpoint, plus 2/5, because that's still the width, of f of 2/5, plus 2/5 times f of 4/5, 2/5 times f of 6/5, plus 2/5 times f of 8/5. Okay, so if I add all that together, that is going to be the approximate area, but we know that it's going to be too large. Right? Notice I didn't use the 2 because that would not have given me a rectangle. So how do you get this f of stuff? Well, remember, f of x was 4 minus 2x. Right? So I would get a calculator and so, all right, I want f of 0, so that's 4 minus 0, which is 4. I need f of 2/5, which is f of 0.4. Either way you want to do that. And so that would be 4 minus 2 times 0.4. Use a calculator. So f of 4/5, which is the same as f of 0.8, f of 6/5, and then last but not least would be f of 8/5. All right, as I was doing my calculations, I did catch a small mistake that 8/5 is 1.6. All right, so those are all my heights of my rectangles. Now, what are all those heights multiplied by? 2/5. So I could multiply each of these by 2/5 and then add them together, but I think I'm going to do this. I'm going to say 2/5 times 4 plus all of these numbers. All right, so 2/5, remember, is 0.4. So I'm going to add all those numbers up, and I get 12. And 0.4 times 12 is 4.8. So that is the approximate area using 5 subintervals with the left endpoints. Let's compare that to the exact area. Okay, remember the exact area was 4 square units. And as we look at this picture, because all of our rectangles came above the function line, our approximation should have been larger than 4, and it certainly was. Let's look at part C. It says repeat part B, but with 10 subintervals of equal length. Oh my. Again, it's just a lot of calculator work. So again, I've tried to draw the picture. So this is still 0 to 2, but I've divided it into 10 subintervals. So this time the width is going to be 2 minus 0 over 10. So that's 2/10, which is 0.2, which was half of 0.4. And so I'm going to use my left endpoints. So again, if I draw each rectangle, notice the last one, if I'm using the left endpoint, is not going to be 2, but it's going to be 1.8. So this is 0.2, 0.4, and so forth. So that's the width. Now I have to determine the height. All right, so I have to go through all of that f stuff. So I need to evaluate the intervals at f of 0, So we should have 10 intervals, and again we're going to be using the same function. Remember, the function was 4 minus 2x. So I'm taking all of these values here and plugging it in for x and cranking out the heights of all of those triangles, some of which I have up here. I just need to fill in the ones I don't have. So those are all the heights of all of these triangles using the left endpoints of those rectangles. Okay, so we should remember when we used 5, we got an area of 4.8, which was way over the limit. So we're still going to be over the limit, but let's see by how much. All right, so we're going to take, remember the area is going to be the width, and this time the width is 0.2, and it's going to be multiplied by all of these added together. So if I'm punching it in my calculator correctly, I have the area is going to be 0.2, and the sum of all of that is 22, and I get an area of 4.4. So that's a better approximation, but still larger than the exact one. So let's go back to the problem. Part A says to sketch it, and I found the exact area using geometry by using the area of a triangle. Part B, I used a Riemann sum, which is just a bunch of rectangles, and I used 5 of them, and I used the left endpoints, and I got an area of 4.8. I repeated that process with 10 subintervals, and I got an area of 4.4. Remember, the exact area was 4.0. So part D says compare. Well, obviously, I'm getting closer. Do the approximations improve with the larger n? Yes. So if I used 5 here and I used 10 here, I'd even get a better approximation if I used like 100, which I certainly don't want to do. Let's look at this problem. This, we do not have a formula to find the area because it's a parabola. We have let f of x be x squared. Compute the sum from interval of 2 to 4. So this is 0, 1, 2, 3, 4. So I want the area bounded by the function, the x-axis, and the vertical lines 2 and 4. I want that area. How can I do that? Well, it says use Riemann sums, which is rectangles, and I want the representative points to be the midpoints, not the left, not the right, but the one in the middle. Okay, and the first one is to use 2 subintervals. So let's look at that. So 2 subintervals. Well, I believe if I split from 2 to 4, so the width, just to do the calculation, would be 4 minus 2, that would be the endpoints, divided by n, which is 2. So the width is 1. So from 2 to 3 is 1. So I've got those triangles, but I want to use the midpoint. So the midpoint is here. The midpoint is here. So I'm trying to find the area of that rectangle and this rectangle. So what is the midpoint? I need to know what that is. Between 2 and 3 is 2.5, and between 3 and 4 is 3.5. I need to find f of 2.5 and f of 3.5. That's going to be the height of this rectangle and this rectangle right here. That's f of 2.5 and f of 3.5. So my function is x squared. So I need 2.5 squared and I need 3.5 squared. So I have my height, I have my width. So the area would be the width times the sum of the heights. So I have 18.5 square units. Now I'm going to repeat the process except using 5 subintervals. So theoretically I should get a better approximation. So I want 5 subintervals. So I want the width to be 4 minus 2, use your endpoints, divided by n, so that's 2/5, which is 0.4. So you don't have to draw this, just really want you to see this. If I can divide this up into 5 equal parts, kind of get the idea here. The problem is using the stupid midpoint. I don't really like that, but we got to go with it. So we want in between here. How do we get that value? Okay, well, let's just kind of look at it common sense wise. Is the first endpoint is 2, and I have a width of 4, so this is 2.4. So what is in the middle of 2 and 2.4? Well, you would add them together and divide by 2, or just look at the middle, it would be 2.2. So if the first midpoint is 2.2 and your width is 0.4, so the next one would be 2.6. I've added 0.4. The next one would be 3.0. The next one would be 3.4, and the next one would be 3.8. So that's the heights you want to compute, and that's going to be all of your height, but again your width would be 0.4. So I'm going to do f of 2.2, 2.6, and so forth. Remember, my function is that value squared. All right, so I have all of the heights. So my area is going to be the width. Remember, it's 0.4 times the sum of all those heights. And I get an area of 18.64. Right, so with 2 subintervals, I got 18.5. With 5 subintervals, I got 18.64. So on part C, it says use 10 subintervals. Okay, so I want 10 subintervals. Okay, I'm not going to draw all those, but remember we started at 2 and we're going to end at 4. So determine your width would be 4 minus 2 divided by 10. That's 2/10, or 0.2. Here's 2, and I would move over to 2.2 and then 2.4, but I want the midpoint. So I need the middle of 2 and 2.2, which is 2.1. So the first height is at 2.1. The width is 0.2, so I'm going to add 0.2 to each of these until I get 10 of them listed. Okay, so that's all 10. Hopefully, again, we're finding the width. We don't want to start it at 2. We don't want to start it at the next one, which would be 2 would be the left endpoint, 2.2 would be the right endpoint, and 2.1 is the middle. And then each one is separated by the width of 0.2. So keep in mind my function was x squared, so I'm going to square all of those numbers. Okay, so now these are all the heights of all 10 rectangles. So again, I'm going to find the approximate area by taking the width multiplied by the sum of all those heights, which I'm not going to rewrite again. I'm just going to add all of those 10 numbers together on a calculator. And I get a sum of 93.3, and now I get an area of 18.66. So with 5 subintervals, I had 18.64. With 10 subintervals, I get 18.66. So if I go back to part D, it says, can you guess at the area of the region under the graph? Well, let's see. We got from 18.5, 18 point something, and 18.66. Well, if I was guessing, I'm thinking it's getting really close to 19. Maybe it's 18 and 2/3, since 0.66 is repeating, would be x and 2/3. That's my guess. It's just a guess. And in the next section, we will learn what the exact answer will be. Let's look at this question. It says, find an approximation of the area under the graph of the function 4 minus x squared, which is another parabola, from -1 to 2. I want to use 6 rectangles, and I want to use the right endpoints. You don't have to draw the picture, but just to let you know what that picture looks like is that part of the parabola. Actually, since it starts at -1, you get something like this. So we want to find the area of that graph. But you don't need to draw the picture. Let's just do the algebra. All right, so first of all, to determine the width, you want to take the right endpoint of your interval, which is 2, and subtract your left one, which is -1, and divide by n. So that's 3/6 which is 0.5, and it's okay to use decimals. Now I need to know the height, but I want to use the right endpoint. So if I started at -1, that's not on the right, that would be the left. How big would be the next rectangle? So instead of drawing the graph, let's just look at the number line. So -1 to 2, if I go over 0.5, that's going to be -0.5. Go over 0.5 again, I'm going to get 0, 0.5, and so forth. So my first rectangle, I want to use the right endpoint. So that's going to use that number. So I have f of -0.5, and then I'm going to add 0.5 to that, add 0.5, add 0.5, add 0.5. Let's see, I've got 1, 2, 3, 4, 5. I need 6 of them. Okay, so I'm going to end up at 2 because that's on the right-hand side. Okay, where do I plug those numbers into? I plug them into the function of 4 minus x squared. Okay, so again, taking each of these values, which would be the right endpoints, and plugging it in there, those are going to be all the heights of the 6 rectangles. Okay, and remember the width was 0.5. So my area is going to be 0.5 times the sum of the heights. So I'm going to add up all of these numbers. That's going to be the sum of the heights. And so I get a sum of 16.25. I'm going to multiply that by 0.5 and get 8.125. And so that's the approximate area of that graph. So we're going to do the same problem, except this time we're going to use the left-hand endpoints. So my function is the same, my interval is the same, I still want to use 6 subintervals, so the width is still 0.5. But as we look at the number line and we talk about our 6 rectangles, 1, 2, 3, 4, 5, 6, and of course they're not all even, but just kind of counting out 6, and I want to use the endpoints on the left, that would be at -1, but it would not end at 2. We've got 1, 2, 3, 4, 5, 6 left endpoints. So it's almost the same, but our beginning and ending is different. Here on the right endpoints, I started at -0.5 and I ended at 2. For the left endpoints, I'm starting at -1 and ending at 1.5. So I certainly can use some of these same values. Okay, so my area is going to be the width, again, times the sum of the heights. So that's 0.5. This time I get an area of 9.625. So using the right endpoints, I got a smaller area than I got with using the left endpoints. Now we're going to do the exact same thing except using the midpoints. So remember we have our function, sorry that's x squared, from -1 to 2, and n is 6. So remember the width hasn't changed, is 0.5. But if we look at this 6 rectangles, and again remember those aren't all the same, instead of using the left or the right, we want to use the midpoints. Now the midpoints are still equally spaced at 0.5, we just have to find the first midpoint. Well, there's a couple of different ways to do that. I just look at say, okay, the first point was -1, and if I take the width at 0.5, so the next point would be at -0.5, which we've used. So the midpoint would be -1 plus -0.5, and divide that by 2, or you should just know the middle between that, which would be -0.75. So my first endpoint is -0.75. Add the width to it, and you're going to stop at 6 of them, because remember n was 6. And again, you're going to calculate the heights by using this function, 4 minus x squared, and all of those numbers are your x's. So my area again is the width, which is 0.5, times the sum of all those numbers. Okay, and I get an area of a little bit bigger than 9. So let's compare. Using the midpoints, I got an area a little bit bigger than 9. Using the left endpoints, I got 9.625, and the right endpoints of 8.125. So the middle ones were in the middle. All you have to do on this homework is to do a lot of calculations. Think about basic arithmetic. What's the left? What's the right? How are we subdividing between two numbers? Draw pictures. It really helps.